Given the function f of x equal to 3 divided by x minus 2 minus 3, write down the equations of the asymptotes of f of x. So the equations of asymptotes that we have are the vertical asymptotes and the horizontal asymptote. So 6.1, for the vertical asymptote, we know that it is represented by x, and to get the vertical asymptote, we know that it is the additive inverse of p, and p in this case is minus 2. The additive inverse of minus 2 is 2. So in other words, the vertical asymptote is positive 2. And the horizontal asymptote is represented by y, and it is equal to q. And q in this case is minus 3. Determine the intercepts of the graph with the axis. So we are looking for the x-intercept and the y-intercept. To get the x-intercept, we let y be 0. In this case, f of x will be 0. We will be solving for x. So 3 divided by x minus 2 minus 3. So we are going to take this minus 3 to the other side. So this is going to be 3 equal to 3 divided by x minus 2. Another way to solve this is you can take this and cross multiply 3 so that you get 3x minus 6. But what I like to do to simplify things like this is to swap these two, right? So in other words, 3 comes to the denominator and x minus 2 goes to the other side. So we will have x minus 2 equals 3 divided by 3, which is 1. So x is the same as 1 plus 2, which is equal to 3. So we get our x-intercept when x is 3 and y is 0. So to get your y-intercept, you let x be 0. So you're just going to say y equal to 3 divided by x is 0. So it's just the 0 minus 2. So we get minus 2 here and then minus 3. This is the same as 1, negative 1,5. So negative 1,5 minus 3, this is the same as negative 4,5, which in fraction form can be written as negative 9 over 2. So we get our y-intercept where x is 0 and our y is negative 9 over 2. Or in this case, I'm going to be using negative 4.5 because conceptually a 4.5, I can see it in my mind. So negative 9 over 2 or negative 4.5. So make a neat sketch. So I'm just going to erase this real quick so that we can sketch. Right, so before we sketch this hyperbolic function, let's revise some of the properties of hyperbolic functions. So in hyperbolic functions, what we get is if a is positive, in this case ax plus p plus q, our a, if a is positive, it means our function should be found in the first and third quadrant, and if it's negative, then it should be in the second and the fourth. So in this case, our a is 3 right here, and I moved the y-intercept to be this side so that I can draw this function right here. So our a is positive because this is the 3, the positive 3. So it means we expect our function to be in the first and third quadrants, right? So now, before we draw any of the function, let's draw the asymptotes. Our asymptotes, we found that our horizontal asymptote is at negative 3. So we're going to have negative 3 down here. So let's assume that this is negative 3 and let's label it y equal negative 3. And our vertical asymptote is x equal to 2. So we're going to assume that this is x equal to 2, like that. So this is minus 3, this is 2, and x equal to there. Our first quadrant is this, right? And our third quadrant is this. So we expect our function to be somewhere in there. So now we're going to plot the x-intercepts and the y-intercepts. So our x-intercept was 3 and 0, so we can expect it to be there. And our y-intercept was negative 4, or was negative 4.5. This is negative 3. Negative 4.5 is somewhere around there. So we can go ahead and finish our sketch. You are going to label these intercepts and say this is your y-intercept and this is your x-intercept by showing the coordinates and stuff like that. You're just going to finish this. So we're going to label this here and label this here. Write down the equation of the axis of symmetry of f with a negative gradient. So how do we get the equation of the axis of symmetry with a negative gradient? We get it by saying y is equal to negative x plus p plus q. This negative is the negative gradient that we're looking for. So if it were for a positive gradient, it would just be y equal to x plus p plus q. In this case, of a negative gradient, we put this negative in front. So we know what p is and we also know what q is. Our p is minus 2 and our q is minus 3, right? So what we're going to have is y being equal to minus into x minus 2, and our q is minus 3. So y is going to be the same as minus x plus 2 minus 3, which is the same as minus x minus 1. So this is the equation of the axis of symmetry of f with a negative gradient. For 6.5 says, write down the range of f of x plus 2. Our function was f being equal to 3 divided by x minus 2 minus 3. So when we add the 2 to the function, for example, we have 3x minus 2 minus 3. So when we add 2 to the function like this, this means our function now becomes 3 divided by x minus 2 minus 1. This shifts our horizontal asymptote by 2 units up. So in other words, our horizontal asymptote will be somewhere around there. So if our horizontal asymptote is there, it means our range now, our y value can be anything, but y cannot be minus 1, because at minus 1 we now have our new horizontal asymptote. It means y can be anything, but y cannot be negative 1. So y is an element of all real numbers. That means y can be any number but cannot be minus 1, because our new function has a horizontal asymptote at minus 1.